Hello everyone, welcome to today's class. Here we have this simple proof before us here. The question says, show that 5 plus 5 is equal to 0 all over 0. You and I know very well that your 5 plus 5 in base 10 is equal to 10. So how do we prove this challenge here now? It is easy. So let's take our solution here. First thing first. Okay. So for us to show that 5 plus 5 is undefined or indeterminate, then we got to do some simple substitution at first. Okay. So in this list, we got to say let's take let's take our x, let x be equal to our 5, and again we got to bring in another alphabet to represent this second 5 here. So say y, let y be equal to 5 again. Again, this is just a logical work here, okay? You may leave your comment in the comment section at the end of the day, okay? It's for fun. All right. So from here, we're going to do some manipulation from here now, right? So if we are saying x is equal to 5 and y is equal to 5, so we're having here 5 here, we're having here 5 also. So we can equate these two terms here now, right? So we can say here, x will now be equal to our y. This is what it implies, right? Good. So if we have x is equal to y, what we do here, we want to square both sides of the equation. I dropped a challenge of this kind on this channel already. Okay, I'm going to leave a link in the description below where you can access that question. Although that one is to show that 1 plus 1 is not equal to 2. I apply a similar approach to proving that also. All right. So if we are saying that x is equal to y, because here we are saying that this is equal to 5, this is equal to 5. It is clear, right? Good. Now, we want to square both sides of this new equation here now. Let's call this equation x. So let's give this equation, let's give this equation star rather, okay, because we're having x as a variable in the question. So if we square both sides of the equation, this is going to give us x to the power of 2 is equal to y to the power of 2. Bring this to this side of the equation to give us x to the power of 2 minus our y to the power of 2 equal to 0. So with this we have here, we apply difference of two squares, which says that if you have your a r to the power of 2 minus b to the power of 2, this is equal to your a plus your b, bracket a minus your b, right? So we can apply that here. So here this is going to give us our x, there plus our y, or in bracket our x minus our y, bracket this is equal to 0. Okay. Now, of course, we have what we call the zero product here, whereby we can equate this to this, equate this to this. But if we go into that, it's of no use. All right. So what we do here now, look at what we are asked to prove here now. We're saying this plus this is equal to 0 all over 0. Okay. Now, how do we achieve this? It is very easy. We know that this is 5 plus 5, and this is 5 minus 5, right? Good. So ideally, if we go by the standard of base 10, this is 5 plus 5 will give us 10 here, and 5 minus 5 will give us 0. So 10 times 0 will give us 0. So 0 is equal to 0. So this expression, according to a normal binary system, that is a base 10 system, this is correct. But this is what we're going to do here now. We have x plus y here, which is 5 plus 5 here. Then this now, we have to eliminate this. How do we eliminate this? We divide by x minus y. So here we're going to say divide through by x minus our y. We equally divide this by our x minus our y. So this leaves the system. So here we're going to have our x plus our y is equal to, we have here 0 all over. What is our x? So recall, we said let x be equal to 5 and also y be equal to 5. So we can put back our value here, which is 5 minus 5. Okay, so let's continue here. So this is going to give us our x plus our y is equal to This is going to give us 0 all over, what is 5 minus 5? Oh, that is 0. So this is going to give us 0 here. Now let's go to the left-hand side of the equation where we have this. Recall that we said x is equal to 5. So from here we can say recall, okay, that your x is equal to 5 and your y is equal to 5 also. So let's replace that back again to the equation. So this is going to give us our 5 plus our 5 is equal to 0 all over 0. This is what we are asked to prove. So proved. Okay? So this is proved. All right. Again, this is for fun, by the way. So drop your comment in the comment section. I will see you there. Thank you for watching. See you in our next content or in our next video. But till then, keep winning.